All right, let's jump in. Welcome everyone to this Mapbox webinar on traffic data with isochrones. So I'm Chris, I'm a developer evangelist here at Mapbox. I'm joined today by Kuan Butts and Jamie Saxon. They're both senior software engineers that work on our telemetry team. So they are the ones who can analyze all this data and turn it into real-time traffic. And we're going to see today how that interplays with our directions API or with our isochrones API. And all the great things you can do with the combination of real-time data and this amazing service. Can you hit the next slide, please, Jamie? So you're probably already familiar with Mapbox if you're here, but if you're not, go ahead and check out mapbox.com. We'll be looking I guess we're in the navigation and data realms today, but we also do, top-notch, very performant map rendering, and we also have search functionality. So APIs for whatever you need for your location-based services or location-based app. Next slide, please. All right, so this is our plug to join the Mapbox developers Discord community. So if you're building with Mapbox, this is a community space where you can find others who are using the same tool set as you, see if you can get help, post your problems, and there's lots of Mapboxers hanging around, lurking and actively helping in there as well. So join the Discord if you have a moment. And yeah, my last thing I'll say before I turn it over to Jamie is if you want to drop your questions in the chat, I'll be moderating a little bit throughout this presentation, and I'll take your questions and pass them on to the presenters. So just drop them in the chat, and I'll also be posting links and things as they present whatever's relevant. So keep your eye on the chat window. And without further ado, I'll turn it over to Jamie Saxon, and let's learn about traffic data with isochrones.
So before we start, let's quickly talk about what an isochrone is. So an isochrone will tell you effectively the total area that you can reach in a given amount of time. So you can see, for example, in this image, you can see the distance you can travel from that. You can see the distance you can travel from that initial pin that's been dropped in Jersey City, and you can see the walking distance you can reach in 15 minutes, 30 minutes, 45 minutes, 60 minutes. This isochrone is generated using the walk network of Mapbox's internal data set to allow us to figure out what roads can be traversed and how far you can go down them within that time frame. If you go to the next slide, you can see this is a common kind of old school, if you will, isochrone, and it's just taking a buffer of the area around a particular start point. And you can see the limitations of this, for example, precisely. You can see that we've highlighted that if you just do a simple 15-minute buffer around Hoboken, you'll purportedly be able to walk into the island of Manhattan across the water. Of course, you can't actually do that, and that's where things like isochrones become helpful, because they actually help to highlight, if you can go to the next slide, places you can and can't actually reach in a given amount of time. And it's not just the road network, of course. With Mapbox, we actually have a very large historical and real-time driving data set that allows us to know typical speeds and traffic volumes along roads throughout the world. So you can see in this the same example, looking at where you can reach from that same start point in 15, 30, 45, and 60 minutes via car, for example. And you can see how traffic patterns, existing freeways, various closures, congestion incidents, that type of information can help facilitate the shape of the isochrone at each time threshold break. Next slide. So yes, so as you can see, especially from the drive data set, knowing the speed along a road is incredibly important to determine how far you can actually go. So for today, we'll actually have a few examples of how to use isochrones, and then we'll also discuss how live data feeds into that and how Mapbox's unique kind of data source, which is its live data pipeline and its historical data pipeline, can help create extremely accurate versions of isochrones for utilization in various contexts. Next slide. So for our first example, what we'll do is we'll actually use an isochrone to determine what's called ingress-egress, so the ability to get to or from particular areas. And in this simplified case, we'll actually look at essentially fire risk, or the ability to leave a parcel and access a safe area from each parcel in a high-risk fire zone. And the goal of this will again be to utilize the output of the Mapbox isochrones, as well as to determine the coverage of any egress route, so the time to reach any of these multiple points of interest. If you go to the next slide. So you'll see, just to kind of give a specific location to this example, just so we can work through, we'll use my location where I'm at right now in Oakland, California, and we'll actually look at this hills area, which actually had a significant fire, I believe, in the early 90s. And since then, there's a lot of focus on how quickly can you leave, exit, or get to the parcels up in these hills. And you can see, of course, in the yellow, there are freeways throughout the city. And typically what's intended is how quickly can you get to those freeways? Can you get to those freeway on-ramps? So if you go to the next slide, you'll see what we've done is we've highlighted here the road network, and we've identified the particular on-ramps onto the freeway throughout the city. Of course, we've looked at the entire city, but what we'll want to do is we'll want to say from this target area, which is the nearest on-ramp and how quickly can we get to that to exit this high-risk fire zone. And how quickly can we do that? So if you go to the next slide, again, in this example, we'll use parcel data. So we'll actually be looking at every single parcel in this particular set of neighborhoods. And then we'll want to be going, and then if you go to the next slide, what we'll want to do here, and this is just a quick little bit of code to show you how you'd format this call. And before we dive into that, if you click on the API playground, you can actually, if you're ever curious, you can just, the Mapbox documentation actually has a number of these playgrounds available. And in this case, there's one, Chris just shared it, where you can actually format your API call by interactively, by dragging your marker around, setting your breaks, looking at how many, looking at if you want to be looking at driving versus real-time driving versus walking, and then design even the response shape. For example, the color of the response, the style of the GeoJSON object that's returned precisely. So you can see here, Jamie is selecting multiple breaks and then looking at the total access zone from a particular start point. Okay, so if we switch back over to our example, you'll see what we've done is we've actually taken in that first set in the code that's been shared there. You'll see this thing called subnodes, which is basically we're looking for each freeway on-ramp that's within some approximate distance of the target neighborhoods that we're looking at. And then from that subset of freeway on-ramps, so the freeway on-ramps that are in the general vicinity of the specific area that we want to look at, we're going to format a query. And you can see the query has been formatted here. And of course, in that interactive demo that Jamie just went to, it's also formatted, or it's also demonstrated and formatted there. But we introduce a few key pieces of information, and you can see that they're in the string that's being formatted here. So the first is profile. In this case, for this example, we're going to look at typical traffic. So we're going to look at Mapbox driving. So this is typical speeds along this road, or the average speed during the day and night along this road. And then we're going to look at the coordinates. So the particular coordinates that are from the origin, so the latitude and longitude. Next, we'll look at the contours in minutes. And just for this example, since this is a high fire risk zone, you want to get out of it quickly, I chose just increments of 2. So 2, 4, 6, and 8. How quickly, how many homes can get to these points of interest within 2 minutes, 4 minutes, 6 minutes, 8 minutes? And then, of course, what we want in response is the GeoJSON. So we'll ask for the polygons true, and then just include our Mapbox access token. So of course, the subsequent portion is just simply making those set of API calls, receiving the result geometries, and then adding them to a parsed geometry list. So if we go to the next slide, here we can actually see visualized the risk by parcel for the entire target neighborhoods in the Oakland Hills here. And what we've done here is we've actually just colored the results. So you can see the lighter green is 2 minutes. So that's if you live in these parcels, you can get to a freeway within 2 minutes. The teal is 4 minutes. And then as you get to darker purple, 6 and 8 minutes further and further away. And you can see some portions at the highest point of the hill are beyond that threshold. So again, if you were to, for example, if you were a utility company trying to see what the highest risk parcels in this area were, you could use information like this in all of your zones to identify which were the highest risk parcels, or where did you have utilities running that were in parcels that were hard to essentially escape from. And again, on the code on the left, what you'll see is we're just simply rendering this. So all we're doing is we're unioning the resulting geometries from all of the isochrones that are related, that are in the 2-minute category, the 4-minute, the 6-minute, and the 8-minute. And we are plotting those in this image. I see a question coming in. Do we know the assumed driving walking speed using the isochrone calculation? We don't. The isochrone calculation is returning essentially an aggregation of all of the speeds associated with all of the roads evaluated within that total area. However, if you go to the next slide, that's a perfectly timed question, because we do make available typical traffic. In fact, that's something you can procure from Mapbox as well, which is the historical traffic speeds along every single segment of road that we have historical traffic for. You can see that this is just from the website, this page, but we generate live and typical traffic, and this information is, let's see, another question about regions. I'll follow up on that in a moment. Yes, so if you were to receive, for example, historical data specifically, it'll actually identify each particular road segment and give you a distribution of speeds on that by time of day. I will actually dive into that. Well, let's just go into that immediately. Let's go to the next slide. There we go. Yep. Okay, so as you can see, somebody was asking about coverage. For example, we have global coverage across a number of countries. I see this. I see a question of this working outside of the U.S., and of course we have an example in the U.S. here. But yes, there are a number of other locations for which this data is available. I know we have a lot of coverage, for example, in Southeast Asia, across Europe, and I think if you reach out, we can be a little bit more helpful in providing answers to a specific location. But you can see one of the advantages here with Mapbox is that we have a huge number of we're embedded in a huge number of devices across a vast number of what we call owners or different application types. That distribution allows us to have sort of through the law of large numbers, a very kind of normal distribution in terms of the types of speed observations and driving patterns that we see. And that gives us a good blend of both urban driving data as well as rural and exurban or suburban driving data. If you go to the next slide, there was a question about time of day as well. So our processing pipeline processes a huge volume of data. We'll link later on to a blog post that will give you really the specific details about this. But not only are we processing historical data, but we are processing a large volume of live speeds throughout the day. These live speed probes are kind of broken up, disaggregated, anonymized, and then they are matched to the existing road network, where each network segment is described as a piece of road between two independent nodes, where each node is an intersection. And then it is aggregated on top of the historical aggregation, which exists for that particular time bucket to generate a time of day speed estimate that is then served. That time of day speed estimate is served both for a live and then a historical. So the live exists as a layer above historical. If you go to the next slide, we can actually talk about what the resolution is on that. So as you can see in this diagram on the right, what you have in this example, you have a start and an end node ID essentially, and then you have the speed estimate. And that speed estimate is derived from all the speeds received within that window of time. And each window of time represents a 5 minutes window. So if you see, for example, on the top, there's a road A, road B, and road C. Each one of those has a distribution of observed speeds for that time bucket, and then a speed estimate is derived from that. And that time bucket, again, you see is 9:30 to 9:34. So there are, in a given week, 2016 5-minute time bucket windows. So for a given road segment, you'll have a typical week pattern, which encompasses 2016 independent buckets of time, each representing 5 minutes incrementing throughout that week. On top of that, of course, you also have live data feeding over those historical patterns. If you go to the next slide. Yeah, so just what I mentioned earlier, there is a blog post available that dives into this ingestion pipeline in detail, describes sort of the architecture of how this is ingested, and will help you give an idea of the type of scale in terms of what we're delivering for both historical and live speeds. If you go to the next slide, yes. So now if we wanted to talk just about live speeds in general, so we use the historic as a baseline. And again, each 5-minute bucket has a historical estimated speed. And then what we can do is we can actually look at live speeds and see how live speeds are impacting or relative to those historical speeds. This is a live stream of data that's coming in. It's partitioned by geography. And then for each geography, we actually look at the measurements of speed, look at the significance of the observations, compare that with historical, and then produce a live, essentially a live estimate speed. And these live estimate speeds are derived both from historical and then live data. If you go to the next slide. So just to show kind of what this might look like on a typical route. So, going back to that question about what the live speeds were in the isochrone, if you were to actually look at a particular route instead of looking at an isochrone, or just derive speeds from a particular live segment of road, what you'd see here and what's kind of diagrammed at the bottom, just in a very general sense, is you can see a historical speed, which is the shaded kind of y value, and then you can see the bar, which is the actual live speed, and then in the distance, which is the x-axis, is the distribution or the portion of the total length of the trip for each one of those segments. So you can see how each segment additively contributes to the total estimated time of arrival. For example, when you are looking at, how long does it take to get from point A to point B, a discrete point A to a discrete point B. Next slide. So yeah, another use case of now having these per segment speeds is that what you can do is you can begin to monitor particular segments of road. So this is a kind of interesting example. Oakland and San Francisco are connected by a single bridge, and that bridge has really significant spikes in congestion during particular hours of the day. And you can actually see how that plays out, for example, over a week. And so what we have here is we are just at 5-minute intervals requesting the time, the ETA from downtown Oakland to downtown SF, and the inverse from downtown SF to downtown Oakland. And what you can see, and again, this isn't one particular road segment, it's actually 20 or so, because you're crossing the bridge. But you can see how those 20 cumulatively add up to create different estimated times of arrival at different times of day as a function of both the historical stacked with the live speeds data. Cool. So the next slide. And just to kind of highlight the difference between the two, here's another example of two other control routes. And what you can see here is the difference in these estimates. So you see the yellow line is what the historical would have estimated the speed to be at that particular time of day. So traditionally, let's say getting from Columbus Circle in New York City to JFK, the airport, let's say would take 55 to 60 minutes. And then you can see on this particular day that we were monitoring this control route, we could see that there was additional congestion, additional traffic present on this time of day, at this particular moment on this particular time of day, and that was adding what looks to be about 5 to 10 minutes, depending on the particular time to that trip. You can see the same thing. The other control route here is just to Newark, another airport in the New York City area. Okay, next slide. And before we jump, I'll just review any quick questions before we move to the next section. Any way to use a traffic profile that has unusually high traffic? Yes, so I think a good example of Jesse's question here about using a traffic profile that has unusually high traffic. So if we were to kind of go back to, can you go back 2 slides, Jamie? One example is to either look at historical data and look at like what the peak, the worst case, you could effectively request what is the worst case scenario on that road. Another example is if you do have a control route and you're regularly, pinging that control route and looking at the ETA, you can say, okay, for example, let's say Oakland SF in the middle of the night. This is actually a very fast trip. It's a 7-mile trip, I think. So it takes, 7 minutes roughly. People are driving quickly, but you can say, well, what is like the elasticity of the time of the ETA, right? How bad can the ETA get? The ETA can get very bad on the segment of road. So it can triple, it can quadruple. And so you can know, let's say in a typical or in free flow conditions with no traffic, it might take 7 minutes, but in a catastrophic situation, we can see ETAs of up to X, Y, or Z. And then Artem, I see one other question, which is about specific truck routing. I think that Ryan perhaps can talk about truck routing specifically. I know there is different particular profiles on that. I'll stop at this point and I'll pass it off to the next speaker.
Sure. Yeah, I'll take the trucking. So we are working through a trucking routing profile right now, and it's one of the hardest problems out there because truck routing is not just governed by the federal government, whatever country you're in, but has local and municipal rules that are different for everything. So it's more of a data problem than a routing problem. And we're really working hard to try to put this data problem together so that we can get a comprehensive truck routing product out there and profile so that it could be used. We do, I mean, on the very meta level, there are road network profiles, allows trucks, don't allow trucks, but there's so many other things such as hazardous waste, turn radiuses, overhead clearances, so you don't get your trailer stuck under there. It's a much larger problem that has extremely disparate data sources, and we're working through that. We've got a solution roadmap and are putting together. The thing is with truck routing, because of all of the regulatory issues around it, and that it's not just a one regulatory body, it's multiple local, state, county, what have you, that we want to get it right the first time because the consequences for not doing it right are much more than just making a wrong turn. So we're working through that. Thank you very much for putting that out. Do we want to go to the next slide, or that's good? Thank you. So real reason I'm here today, as said, I'm Ryan Leidig. I am the product manager for all of our logistics products. So Isochrones Matrix and the optimization APIs. And today we're releasing into a beta, or we like call it public preview, that a time-aware isochrone using historic traffic data. We just saw Jamie and Juan just showed us, really cool egress maps. How do you map out the probability of escape from areas? We have customers who use our isochrones, say for real estate, saying, I want to see all the houses for sale within a 15-minute drive of my work. We have customers who use isochrones, so hey, I want to find all the parks that I can walk to in 10 minutes. All kinds of cool stuff. So we do know, because we live in the real world, that the distance you can get in 10 minutes varies by time of day. If you're in rush hour in Denver, it's a total different distance you can get in 10 minutes at 2 in the morning on a Wednesday. So we are to solve this problem, we're introducing isochrones with a depart at parameter for the driving profile. Juan talked about, we have 5-minute buckets. We're going to take we're going to take our proprietary traffic for each time of day of the week and in those buckets for time of day. And we're going to allow you to put a future date in there. So it will use the traffic conditions that are from the past 90 days that are present at that time and at that day of the week. It is going to be, you're going to be able to build isochrones with predicted traffic. You're going to be able to see how traffic patterns change within a certain area dependent on time of day. You're going to be able to build things to understand, the reach of your products, the reach of real life buildings and services based on time of day, so you can have a much more accurate picture of what you're doing. This goes from, we went from the circle that Quan and Jamie showed up front to the highly accurate road network one, and this is now entering a temporal element for the future. We're going to have, it's behind a feature flag right now. Before the end of the week, we're going to have a link in our documents to sign up, and I will authorize your account. It's just adding a parameter into the API call with a date time group, and it'll calculate for the more accurate result. We really can't wait to see what you build with this, and we're really excited to learn how our proprietary traffic helps you solve your problems. So that's what I have. You can always come and, for the live traffic. So it's the traffic profile. If you just use driving, it uses typical traffic. If you use driving traffic, it uses live traffic. If you use driving and then put a depart at parameter in there, then it will use the historic traffic for the day of the week and the time of the day that you're using. So it'll be in the documentation before the end of the week. Sign up, I'll authorize you right away and go from there. So I really appreciate you giving me the time to announce this, guys.
Thanks a lot, Ryan. I'm super excited to see this coming out. And so I want to give just a couple examples of what you can do. I think it's really exciting that this brings a true, right? It's an enormous amount of data. We're going from the incoming, raw location data, the raw telemetry, it gets processed into live speeds. And then you can do really complex analyses with just these API calls that are just leveraging all of that stack up. So without doing any analysis, this is what the depart out feature looks like. So this is looking over the course of a day in Washington, D.C. And you see the isochrones fluctuating in and out as we hit morning rush and then evening rush, and then starting to expand and follow their pattern again. You obviously see the isochrones creeping along the highways. You can see that the west area of the city towards Virginia sort of collapses more. If you pay attention closely, and I'll show this in a graph on the next slide, you'll see that the incoming rush the morning rush, since we're looking at isochrones going out, the morning rush is less severe than the evening rush. And so there's a ton of data. You can see how much this contracts, and so you can see how badly impacted a city is by congestion. There's a lot that you can do with this form of data. So I'm going to go to the next slide. And so what I want to do is get just a little bit more quantitative. It's a pretty picture, but let's think about the reachable population for just one example by time of day. And I'll consider various American cities. I'm going to consider by the top 20 census places, which is jurisdictions. And I will look at it at the census tract level of geometry. So these are places, areas, regions with about 3,000 to 8,000 people in them. So if we take the first example that I showed you visually of Washington, D.C., and we start from the center of Washington, D.C., and then use this depart at feature every 15 minutes throughout the day and say, how many census tracts would I be able to reach starting at this time, at the next time, and so forth. You see that outbound morning rush, this collapses somewhat, but not as badly as the evening rush when people when the roads out leaving the city are much more congested. And comparing the middle of the night traffic with the sort of 5 p.m. rush hour, we can get a sense of how badly congested Washington, D.C. is, or any other city throughout the U.S. So here are my top 20 American cities, and apologies if you don't like my classification for what is a city. Miami maybe should be on this list, but it's a complicated story. Los Angeles, surprising no one, is extremely congested. And so when you have, if you were to leave from the center of Los Angeles at 2 a.m., you would be able to drive to census tracts containing about 3 million people. If you were to leave at 5 p.m., you would only be able to reach the homes of about 1.1 million people. So the congestion, the reachable set of people has decreased by almost a factor of 3, which is pretty ridiculous. New York, I mean, this depends on where you leave from in New York, but is also highly impacted by congestion. And then you can go through the cities, through various cities, and get down to Columbus, Ohio, where pretty much you can reach the same number of people in the middle of the night as at rush hour, which is interesting. So that brings us to the end. Aside from your questions, we've shown you how Mapbox Isochrone API leverages this entire data ecosystem from the raw telemetry up through the driving speeds, and then puts it out in a very approachable, I think, form. I'm really excited that Ryan was able to join us for the release of the depart out parameter in the Isochrone API, which allows you to do these much more granular analyses, allows you to plan out in the future, allows you to compare current conditions with what you would have expected typically, without having to ingest an enormous amount of data. So I can start jumping into some of the questions, unless, Chris, do you want to moderate a little bit?
Oh, yeah, so there was one asked a little bit earlier about applying live traffic data to a routing based on OpenStreetMap data. I assume that means that they're doing, using an external routing engine. But is our live data available in any sort of way that could be joined with another route? or is it more connected specifically with kind of being returned with our data?
Yeah, I mean, so obviously we are based on OSM data. We don't return the OSM node IDs. We do sell that data separately. So if you're trying to spin up your own routing engine, obviously we would love for you to use ours because it's pretty good. But we do also sell that raw data.
So you're saying the raw, just to clarify, you're saying the raw data does include the OSM IDs and could be used?
The raw speed data is referenced by OpenLR, but that can be matched onto the OSM network.
Got it. Okay, awesome. So the next question, is it possible that directional API show me which part of the road reach or limit the height, weight of my vehicle? So I think they're asking about the directions API, and they're asking about the height and weight limits. So I think I can answer that because I helped build the playground feature around this. But yeah, there's a max weight, max height, and max width. And it'll give you it'll try its best to give you directions between your origin and destination that meet those criteria. And if it can't, then it'll include violations in the response. So you'll know that you can put something on the map that says, I'm telling you to go this way, but by the way, you're over height for this bridge or something like that. Does that sound right? Cool. Okay, so another one is, can you build an isochrone based off a region instead of a single point?
That's an awesome question. I mean, that's actually technically what Quan's example did. So if you run several isochrones and say, can I get to any of these, then you would have you would union up each of the isochrones. So Quan, do you want to, since it was literally
sorry about that. Exactly. So if we go back to my example, go one more. So you see the unary. So what happened was, or go back one slide. Or one more. Sorry, just so we get to the freeway. Sorry, yeah, there we go. So we've highlighted the highway on-ramps in this area, and there are many highway on-ramps, of course, in Oakland. But and if you go forward one slide. We just wanted the ones within, and I think I did like approximately essentially a mile buffer of this area. So reasonably, of course, all of the freeway on-ramps within that mile are candidates. And then if you go forward one more, what you'll see is I created this, that's the subnode. So that's the number of freeway on-ramps that are within that approximate area. And those are the ones that I queried for polygons for. And then if you go one more, if you see this definition, this function join isos, so that's just joining the response isochrones. So what it's doing is I'm essentially merging together the GeoJSONs for all of the isochrone responses that were in the 2-minute category or the 4-minute category. And then I produced a kind of union. This is the total area you can reach from all of these particular points of interest. So doing something like that would probably be the most appropriate way of doing a region isochrone, essentially.
Sure. So to summarize, it's not possible with it's not directly accessible just with an API, API call or part of our API, but with a little bit of spatial processing after the fact, you can do something that represents a region. And I think the last question here is, can we do depart at with the Matrix API? And I don't know if any of you can answer that question. Maybe Ryan.
So easy answer, yes, absolutely. It is also behind a feature flag in beta. If you go into the documentation, you will see it's one of the things you can do it, and there's a link to click. We'll put a banner up at the top. We've been meaning to do that, and it's just something that's slipped my mind for the past couple of weeks. But if you sign up for that, I'll give you the feature flag, and you can do the depart at for Matrix as well. There you go. There's the parameter.
Okay, and there's one that almost slipped by me because there is actually a whole Q&A section in Zoom that we tend to not use as actively. But somebody is asking, is the Isochrones API available for Power BI users? Power BI uses it allows for Mapbox integration. So I don't know if anyone else has a better answer, but I'm pretty sure it's actually I don't think actually I don't know. I guess I'll say, is anyone else able to answer that question, because I'm not sure if it's actually integrated into Power BI.
It is not yet. We have started with Snowflake. The Snowflake platform should have isochrones in it by the end of the year, as well as Matrix. They already have our geocoding API integrated. The Power BI stuff each one has its own integration requirements and contracting things as well as engineering things. So we're working through them as we get adoption and requests from customers.
Awesome. So we'll look forward to seeing that at some point. And the last question I see is for traffic data. Can you identify or estimate traffic by vehicle types? How many trucks, how many passenger cars on the road? I'm going to leave that one to our panelists.
So I will say we don't know the type. I don't think we know exactly, the number of different types of vehicles. We do have some traffic volume data and congestion data as part of the movement product, for example. So there's a Mapbox movement product. I think it's mapbox.com/movement. And it generates traffic volume data at quad key level. So essentially kind of a raster of the countries that we service that for, and you'll actually see at least the density of vehicular traffic in those particular areas. There you go. Thank you. Yep.
So to summarize, yeah, we don't have that level of granularity. But okay, so I think that'll wrap us up. So if there's any last minute questions, but you can ask them. But I think we're almost done. So any final words from our panelists? Anything else you want to share as we close up?
Appreciate you having me.
All right. And thanks for showing up. So I'll take us out then. And so looking forward to using the Depart At feature that Ryan was talking about, and go ahead and sign up. Come back and check out the docs. There should be a sign up link on there shortly. And thank you to Jamie and Kwan for showing all of this great insights and all the different kind of downstream analyses we can do with this powerful API. So thank you so much for that. And to answer that very last question, the slides will be up on the recording of this webinar will be up on YouTube tomorrow. So you'll find it on our YouTube channel, just youtube.com/mapboxofficial. And we have a whole playlist for all the webinars. So, and yeah, there'll be plenty of links. That's my job. So I'll make sure they all end up in there. Okay, that'll wrap us up. Thank you all for joining and watching today. Keep building with Mapbox, and we'll see you at the next webinar. Take care.
Bye.